Hey everyone, welcome to hok'stutoring. It's Hok here. Today we're going to be doing question 5 in chapter 15b, which relates to probability, more specifically probability of independent variables, right? So this is the question here. You've got two students have an equal ability in playing an electronic game, so keyword equal ability, so that each of their scores are normally distributed, another keyword here, or key phrase, normally distributed, with the mean of 25,000 and standard deviation 3,000. So yeah, important numbers. The two scores are independent. That's also very important. Independent. What is the probability that in a particular game, the student's scores will differ by more than 7,500 points? So before we get into the question, let's get all the key points down. First of all, we know that we can let x1 equals to the point of student number 1. So student number 1, he's going to get that amount of points in his game, and x2 equals the same thing but student number 2. Okay, and what are we trying to find? So establish the question. We are trying to find the probability. What is the probability that in a particular game the student scores will differ by more than 7,500? So we are trying to find the probability that x1 minus x2 is bigger than 7,500 points. So it differs by more than 7,500, so that's why we have x1 minus x2, student number 1 minus student number 2's points, bigger than 7,500. Of course, we can also have the other way around, so you can go x2 minus x1, but because they share the same mean and standard deviation, you can just multiply that number by 2 to get your answer. Okay, so first of all, we need to establish the mean and your standard deviation of what x1 and x2 minus x2 is. The mean for x1 minus x2, as we know with independent variables, the formula is ex1 minus ex2, right? So in that case, we know ex1 and ex2 are the same. They have an equal ability to play the electronic game, which in this case is just 25,000 minus 25,000. So your mean for the difference in points is 0. That's fine. And then afterwards, we need to find the standard deviation of x1 minus x2, right? Because you have to find your probability, and to get your normal, you need to use your z equals x minus mean divided by standard deviation, right? So we need to get the standard deviation of x1 minus x2 first. How do you do that? We need to convert these standard deviations into variance first. We don't have a formula for standard deviation x1 minus x2, but what can you do? What you can do is square root the variance of x1 minus x2. So yeah, our goal now is to find variance x1 minus x2, which we have learned already. Variance x1 minus x2 is equals to variance x1, and you can split them, variance x2, but of course when you're dealing with variance, every negative sign becomes positive. So you get variance x1 plus variance x2. And in our case, variance x1, because they're the same students, variance x1, variance x2 should be the same, and we are given standard deviation for your points. So in this case, just square your standard deviation. So it's just 3,000 square plus 3,000 square, and if you chuck that inside your calculator, which I believe should equals to 4,242.64. So that's your standard deviation for x1 minus x2. Yep, so once you got your mean and your standard deviation, you can easily find this probability. So let's write it again. It's 2 multiplied by probability x1 minus x2. It can be x2 minus x1, is your choice really. Bigger than 7,500, which in this case is equals to 2 times probability. So we're going to change this into the z value. Bigger than, we're going to change the 7,500 to the z value as well. So it's 7,500 minus 0, that is our mean, so that mean comes right here, divided by our standard deviation, which is the 4,000, right? 4,242.64, and you just chuck that inside your calculator, you should be able to solve for your answer. So the trick with this question is that students usually forgets to multiply by the 2, because the thing is, you can either have one student beating student number 2 or student number 2 beating student number 1. Doesn't matter, it's just the difference is 7,500 points. So yeah, once you do this, chuck inside your calculator normal CDF, your answer should be 2 multiplied by 0.0385, and your final answer should equals to, whoops, it's a bit misaligned, but you should get 0.0771 as your answer. So that's how you do question 5 for chapter 15b. It's not that long of a question, but it's just a bit tricky. So that's pretty much it, guys. Thanks for watching, and I'll see you next week.